Need help? Call our cybersecurity team and book a consultation with us today.
Okay, hello again, everyone. My name is Robert Yee. I'm an SE manager here at Cisco, and tonight we've invited Hesham Fayed, who is a technical solutions architect on the cloud networking team for the Americas, covering the West. Hesham is an expert, a little expert in VxLAN. I've invited him here. He's a member of my team to give you guys an introduction into VxLAN EVPN and a quick demo as well. So Hesham, hopefully I didn't miss anything, but feel free to add a few words and I'll hand it off to you.
No, thank you, Robert. So we'll start the session so we save time. So basically the agenda for today is that we will go through a short overview of the DC evolution, like what type of networks available. I'm assuming if you don't have VxLAN EVPN running, most probably you will have one of these in your DC already. Then we'll go through an introduction on overlay and VxLAN in general. What is an underlay? What is an overlay? Which protocols we use in the underlay and an overlay, how to build the types of design and all of that. Then I will just go for some design options we see from customers as well, and some like kind of best practices or things to watch for when you build your design. Then I will show you a couple of like documents for migration, which is available public documents you can use, because one of the questions always come then, like I'm running this type of networks, how I will migrate from seamlessly from like a traditional type of a 3-tier architecture to a VxLAN EVPN. And then what I will do, I will show you how to build it. I have already a VxLAN EVPN setup. I will show you the management, how it's being built, templates available. And then I will show you another demo as well. If you would like to play with a VxLAN EVPN, there is something called Cisco modeling labs where you can build VxLAN EVPN setup and you can manage it and fully manage, like most of the features available on a hardware will be available on a software. Unless there is a feature which needs some hardware resources like TCAM resources, this is the ones you cannot run, but basically you can test your config, you can do automation, either using Ansible or Terraform or any kind of automation tool you would like to use, any scripting you would like to use, Python scripts you can use as well, again, as a setup. So just 2 VMs and you can have a full setup at your leisure. Basically, if you don't run VxLAN EVPN, most probably you have one of these. So this is a traditional like layer 2, layer 3 type of architecture. You have 2 aggregation switches, you have leaf switches, maybe you have fabric extenders as well, but basically it's 2 aggregation switches. You cannot put more than 2, and then everything is layer 2 connected to those aggregation switches. You have HSRP running on the aggregation switch. Your layer 3 boundary will start at this aggregation layer, and layer 2 will stop at the aggregation layer. Definitely you have spanning tree, and then of course you will have like 1 link active, 1 link passive. Then we came with a VPC design where we still have HSRP running, but basically you have like kind of a VPC or MLAG between the two. The benefit here is that you have active kind of switches, and then your links, all of the links are active. You still have 2 switches, but at least you have active kind of a design, and VPC will be running on the layer 2 switches, your access, or you can call it top of the rack switch. Then we have like the fabric bus kind of a design. And if you look to the difference here is that you really can have multiple layer 3 devices. So rather than you have only 2 aggregation layer, you can have multiple aggregation layers, and you have all your link active going to multiple switches. The good thing is that you can really scale horizontal scaling, and then you can load balance on those links to the switches. But still you have like fabric bus running, but you still, usually you have a spanning tree running in the background just in case if something goes wrong. And still this is layer 2. There is no layer 3 here. Then VxLAN, when VxLAN came, we have VxLAN flood and learn basically. So you can see here the difference is that your layer 3 boundary did move from the spine layer. You can have multiple spine layers, and then it moved towards the access layer. And this is pure layer 3, but you don't have any control plane. It's a data plane learning where you flood and learn MAC addresses. So not very nice, not very scalable. That is where VxLAN EVPN came. And VxLAN added like a control plane protocol It's an EVPN, Ethernet VPN, and then you really have BGP routing running, and you don't have this flood and learn thing. You still have layer 3 towards the access layer, where this VTAP, we will go through the terminologies and what is VTAP is, but you have layer 3, and then you use ECMP to load balance between the links. Two types of designs. The moment we had a control plane, two types of design emerged. One of them is ACI. We are not focusing on ACI because ACI use VxLAN EVPN as well. And then you have the VxLAN EVPN setup. This is what we are focusing today. Both of them use VxLAN in the background. ACI has policy on top, but basically all of them like have layer 3 everywhere. You don't have layer 2. You have multiple spines. It's a 2-tier kind of a design, and there is a control plane running, and you have VxLAN EVPN. When you start building this environment, you know, it's a close architecture. It's a 2-tier, like a spine leaf. But we see a lot of customers today not only running a fabric, because to be honest, it's not practical that if I have like 200 leaves, if I have like pair of leaves, like 100 racks, 200 racks, 300 racks, it is not common that you can have cabling going toward that 2 spines, which you place it somewhere. Most probably you will have multiple tiers, like a 3-tier, where you have a top of the rack switch to a pair of top of the rack switches, and then you have like a middle of row or an end of row, and then you collect all of them connecting together. So today, if you build this, you will have like maybe 2 fabric extenders at the top. Then you aggregate them on a Nexus 5K, and then they go to the 7K. Everything is layer 2 up to the 7K. Or you build layer 2, but spanning tree will be a complete mess, of course. But you have a top of the rack switch, you have a middle of row or an end of row, and then you aggregate this to a core switch where layer 3 is running. The point I want to make here is that don't worry about the VxLAN EVPN 2-tier or 3-tier or N-tier. This will be a routed topology, and it can map to your cabling design. So usually when I work with a customer on a design, we leave VxLAN EVPN logical configs like leaf, spine, super spine, this type of things. And we start focusing first on the cabling design and ports requirement. So we say like, this is the top of the rack switches. This is what I need. I need 100 gig, 10 gig, 25 gig, whatever type of port, copper, fiber, whatever. And then we have a middle of row, end of row, whatever it is, we choose them. And then we go to the next layer. And then after we finish, we start mapping the logical config. So don't worry about like VxLAN EVPN, what is the function, spine, super spine. It's an N layers. It's a routed topology. And we can really match whatever design you have. Just focus on your cabling design, finish that, and then we can map the devices. This is the point I wanted to make here. What is the customer needs when it comes to moving from a traditional 2-tier, 3-tier design to a VxLAN? Most customers like moving because of like they have an end of sale hardware they want to move to. They don't like the layer 2 fabric extender to 5K, 7K buffer issues or whatever problems they have, and they want to move to basically a routed topology and push the routing layer to the edge. So one of them is like when you build a 3-tier and you have your aggregation layer, this is your VLAN. You cannot move VLAN across aggregation layers. So if you have workload and you want to have flexibility to move workload across a DC, some customers have like 2,000, 4,000 switches. They have multiple aggregation layers, and then they connect the aggregation layer to core layer, but definitely they cannot move VLANs across. VxLAN came to solve this issue by having flexibilities that you can deploy VLAN anywhere. Even if you have a layer 3 topology, I can have a fabric A and fabric B, and then you can extend VLAN across those 2 fabrics without an issue. All features will be available, layer 2 will be available across multiple fabrics. VM mobility, like someone want to do vMotion across multiple layer 3 boundaries, this can be done as well in a VxLAN EVPN, no problem. Scaling VLANs as well, over 4,000 VLANs, because VxLAN came and give us 6 million segments. Because VLAN, like I can have VLAN 4 and VLAN 10 and they can talk because of the VNI, which we'll go through. is the same. So I can scale by mapping multiple VLANs to different VNIs. I can, or the same VLAN to a different VNI, I can scale over 4,000 segments. Efficient use of bandwidths, because we use equal cost multipathing. All the links between your leaf switches where your servers are connected to the spine switches, you can have whatever number of links, and then you can use equal cost multipathing, and you can start load balancing on those links as well. So it gives you really an efficient use of your bandwidths, because I can have 2 spines, 4 spines, 6 spines, 8 spines, and I can scale, or I have multiple links going to the same switch. If someone wants to deploy multi-tenancy as well on a VxLAN EVPN, it's not a problem, because you can deploy multiple VRFs, and multiple departments, multiple customers can exist on the same infrastructure, because it is a multi-tenant ready by design. This is the packet format of a VxLAN. I will not go through each one of them, but the point I want to make here is that VxLAN is a UDP packet. You have a source IP, destination IP, you have a source port, destination port, and protocol. Protocol is UDP, destination port is 4089. The source IP and destination IP will be something we will cover, which is called VTEP, which is a loop back on switch 1, and then another loop back on switch 2. So basically the source port is the only difference here. The source port is a hash to the full inner header, which is the main header of the packet you want to send. That means that if you don't get really randomization on the IP addresses to generate multiple UDP port, if you deploy like 8 links 100 gig from one switch, you may find yourself polarized to one of the or 2 links. So the point I want to make here is that if you go for a switch with multiple links, make sure that your IP addresses is really randomized, or you start going from 100 gig to a 400 gig. So if I have a 100 gig switch, it's much better to use 400 gig uplinks rather than going with 100 gig uplinks. If I use 1025, depending on your over subscription ratio, just make sure that your IPs is randomized. Otherwise, you will see that sometimes some links is not utilized as other links. The other point is that the VxLAN header add 50 to 54 bytes. If the customer use VLAN tagging, it will be 54. If it doesn't use VLAN tagging, it will be 50. This has to be calculated in the MTU calculation. So if you are going across DCs, you are connected to an MPLS cloud or something, you have to make sure that you accommodate for this 54 bytes. Otherwise, you will have issues to form links. If we look to the naming and convention before we go to the design, so we will have leaf. Let's start with one fabric. So you have a leaf, which is the L is leaf and S is a spine. We call this edge device because this is where your VLAN terminate. Definitely VLAN has to be terminated because the servers will be connected to an access port, or maybe you have an ESXi with a trunk port connected to the leaf. So your edge device, this is where your VxLAN encapsulation will start. Then you have layer 3 point-to-point links between the leaf and spines. We call this underlay because we have only loopbacks. The customer traffic is not existing in the underlay. The underlay, which is we build with this point-to-point links and we have a routing protocol running, is to help us to reachability information between the leaves. So when we build this network, all what we want from the underlay is the point-to-point links, and we can use IP unnumbered, so on the loopback. So basically, we are carrying loopback interfaces in this underlay protocol. This protocol can be OSPF, ISIS. Some customers like to use BGP. We'll go through that. But this underlay network only carrying our loopback IP addresses. It doesn't carry anything of the, like if you go there and you try to ping one of the host IP addresses, you will not be able to. There is no VRF there. It's just on the global routing table, basically. Then you have the LAN segment, which is your VLAN, basically, which will map to something called VNI, VxLAN Network Identifier. So, and we start building your overlay. The overlay, the moment we start saying overlay where your customer traffic will run. So we have something called VLAN VxLAN tunnel endpoint, which basically a loopback running on this leaf switch, top of the rack switch. And then tunnels will be created between the leaves. So if I want to access host 1, want to access host 2, what will happen? The traffic will reach the leaf. It will get encapsulated into VxLAN, and then it go through the spine tunnel, go through the spine, terminated to the destination leaf on the VTAP, decapsulated, and then the traffic will go to the destination host. To build the underlay itself, there is multiple options. You can go with OSPF, you can go with ISIS. What I see, usually customer go with OSPF, and usually the reason for going with OSPF is basically because most of them familiar with OSPF. Not much customers really familiar with ISIS, but we support OSPF and we support ISIS. With management, you really don't need to worry about configuring OSPF or ISIS, because with management, which I will show you, all what you need is to choose the routing protocol. You say, I want to use OSPF. You give a couple of subnets, and basically we will go and build it for you. You don't need really to touch. And the underlay usually it's one-time config, basically. It's only added when you add additional leaves. It will join the underlay by configuring some loopback on it and OSPF. Very basic config I will show you as well. But it's very, very basic config. I like to use OSPF in the underlay because I like to have different routing protocols. And I will show you that if you start going with BGP, which we support as well, there is some things you have to change to make sure that things work properly. But what I see, most of customers like to use OSPF. And overlay, the only option is really BGP. So you cannot use any other protocol. It has BGP. Some customers like to use in the underlay BGP. So there is two types of design. There is a 2 AS design where all the leaves are in the same AS and all the spines is another AS. And there is another design which is available as well, which is like each pair of leaf, like if you have a VPC pair, each pair of VPC pairs will be in its own AS. We support this. There is design documents for it. It is supported, but I feel it's very complex to just run loopback addresses in the underlay. OSPF is very straightforward, couple of commands. You don't even need to touch it. The license you will get with the switches, you will get the management license. So you are not even paying anything additional to get the management software. The management software is included with the basic license you get with the switches to run VxLAN. And we will build it based on Cisco best practice as well. You don't need to fine tune anything. OSPF will be deployed based on Cisco best practice. This is to show you that you can build multiple fabrics. So I have a leaf and I have a spine, and then I have a super spine. So think about the leaf as if you're top of the rack switch, your spine maybe a middle of row or end of row, and then your super spine is your switches or couple of switches connecting this rows really together. So if I deploy just VxLAN EVPN, so VxLAN is running on the leaves, the spines is really running BGP mainly. They are aware of EVPN address family, so they can carry this information. And the super spine really is running BGP, pure BGP, no VxLAN EVPN whatsoever. So you basically build multiple ASs. Between the spines, it will be really eBGP. Within the DC, it will be iBGP. This is assuming that you are running IGP in the each fabric, basically. So I'm running OSPF maybe or ISIS. Otherwise, you will see that this drawing can change by having the spines to have another AS and leaves depending on 2 AS or 3 AS design, multiple ASs. So if you look to the control plane, how the routing will take you, you will see that if host 10.1.1.10 want to reach 10.1.1.20, which is in the same VLAN, they are in different fabric across layer 3 boundary, and they want to reach each other, you will see the next hop point to a VTEP, which is a loopback on one of the leaves, or the leaf which is connected to that host. So the moment you go to the control plane by running a command, usually show BGP, EVPN, L2 EVPN, you will see that your next hop is the VTEP. So there is encapsulation will happen between the leaf, source leaf to the destination leaf, a VxLAN encapsulation, where the original packet will be encapsulated and then sent across to the other side, basically to the next hop, which is on the other side. So one of the things, the reason I put this slide, so one of the things of doing such a design is that all the leaves in one fabric need to pair with all the leaves from the other fabric. So definitely this design is a valid design. But if let's assume you have a 512 leaves, this will be a big routing domain. The other thing is that remember always that if you extend VLANs everywhere, you will always learn local MACs as well as remote MACs. So depending on how many MAC addresses you have, your leaf from the other side will learn all these MAC addresses. So let's assume you don't have an interest in the VLAN over there. So you really you will see that if you do show NVE peers on one of the leaves, you will see the peers on the other side. There is another way to design this by building kind of a multi-site. So the difference is that you have a leaf and spine, and there is a function running on the leaf which called border spine. So the border spine, what will happen is that you will still have multiple ASs, multiple BGPs, but what will happen, let's go to, so you can see the encapsulation. So local leaves will peer with each other, so in each fabric. So when you show commands to see which peers this leaf can see, you will see the leaves with local fabric. And then you will also peer with the spine, which is called border spine in this case. But in case if you want to reach to the other side, your encapsulation will be to the border spine, which is this spine, and then this border spine will peer to the other side. So you don't peer with every leaf inside inside your DC. Imagine someone has like 3,000 leaves or something, and he want to create this. Definitely going for a kind of a multi-site, even within a DC. We call it multi-site, multi-fabric. This design is very scalable. We can scale up to 25 fabric. Each fabric has 256 leaves. So this more than 6,000 leaves in one place. This is a lot of leaves. So your leaves will peer with each other locally, and then the border spines will peer with each other. So this is very scalable. The other thing is that with this design, you will see that you will still have multiple ASs, but this 10.1.1.0 will see next hop as 10.1.1.1, which is basically a host within the same fabric. But he wants to reach to the other side, he will see that he can reach it through the border spine in his site. So basically what will happen is that the leaf will create a VxLAN tunnel to the border spine in the local site. And then the border spine will do encapsulation, decapsulation. So it decapsulate, look at the inner header, see where this is going. And then he will know that, oh, this is available on another border spine, which is on the other side. So what will happen? He will do encapsulation to the other border spine, and the border spine will encapsulate, decapsulate, and then do a VxLAN to the other leaf. This is all done in hardware. There is no impact on performance. Everything is done in ASIC. There is no impact on the CPU. This design is much more scalable because if you are not extending your VLAN to the other side, you are not interested. What you will learn is a prefix route, is a subnet route. You will not learn the host IP address on the other side. So your VLANs, your MAC addresses will be local to each site. If someone wants to communicate with another VLAN, which is happen to exist on the other side, he will see it as a layer 3, layer 4, layer /24, whatever the subnet is, locally on the site. and he will not see the MAC addresses because he doesn't have. So what will happen, we will not publish this subnets on the border spines. So that's why we are not sending all these IP addresses, because if you want to communicate with a VLAN on the other side, you need to know the host IP addresses, because the VLAN is existing on both sides. If you are not, if it doesn't exist on the other side, you will only learn a /20, the subnet route, the prefix route, basically. So tunnels created this way. This is very scalable, and you can fine tune because each one it has its own underlay and overlay. So IGP is local, BGP is local, and it's considered multiple DCs rather than one gigantic DC. This is something very important as well, because when you want to troubleshoot, or you want to know, like, did I learn my MAC? I'm not able to ping. Can I see this MAC/IP in my leaf to be able, like, to ping the other side or not? So there is different route types when you run this command, because you need a new set of commands to be able to run and understand what's happening. So when you run like show BGP, L2VPN, EVPN, you will see this type of output. So there is something called route types. So route type 1, usually you will not see in Nexus 9K. This is basically because we use VPC, but if there is like a Broadcom ASIC, like we have Jericho ASICs where we have something called the Ethernet segment ID. This is basically for multi-homing. So if you have two leaves and you have a host want to connect to those two leaves, there is no VPC config, virtual port channel config. We'll use this ESI concept for multi-homing. So this is where you will see type 1. So type 1 is exchange between two leaves as pairs. So if you have like leaf 130, 131 and 132, and you have a host connected there, this is where the type 1 will be exchanged between leaf 131 and 132. We use VPC, so you will not see basically type 1 routes. Type 2, this is what you will always see, because like when you have VLANs and MAC addresses, usually it's type 2. It's a /32 basically route. Type 3, we have, there is something called bump traffic, broadcast unknown, unicast, and multicast. So if you don't like to run multicast in the underlay to be able to forward broadcast unknown, unicast, and multicast, we can use something called ingress replication, where this bump traffic will reach to a leaf, and the leaf will send it to everyone else. So we use it basically between the border gateways, and you can use it as well locally. Sometimes customers say that we are not really familiar with multicast, we don't want to use it. So ingress replication is one of the options. So type 3 route is used basically to discover the peer, so you can do the replication to them. So if you use ingress replication, you will see a type 3 routes available. Type 4, in this environment, you will basically see it on the border gateway. Type 4 is used to because if I want to forward broadcast and unicast and multicast to different fabrics, we have to elect something called designated forwarder. So designated forwarder will be one of these border gateway. Each border gateway will be responsible for a couple of VLANs. If you have 4, they will all participate, and each one of them will choose a couple of VLANs to be able to forward bump traffic. So when you run border gateway, there is type 4 route being exchanged between them, and you will see it on the border gateway. You don't see it on the leaves, but you will see it on a border gateway. If you don't have border gateway, you will not see type 4 routes, basically. Type 5 routes is the prefix routes, which is the subnet routes. So if you are doing redistribution, if you are not advertising this VLAN on a border gateway to the other side, you will receive a prefix route, and the prefix route is basically a type 5 route. Any questions so far before we go to some design options? Robert, is there any question on the chat?
I haven't seen any yet, Hesham. I will. I'd say keep going, and I'll interrupt you if I see anything.
Okay. So when we do the leaf and spine, remember always that when you want to add more leaves, when you want more ports, you add more leaves. So basically, if you want more bandwidth, you add spine. So if I have like a spine which has like 36 port, you can connect up to 36 leaves, because at least the leaf will have one port on that spine. But if you have 37, this 37 leaf doesn't have enough port on the spine. And even if you add multiple spines, it is expected that all the leaves will be connected to all spines. So just remember this, you have to choose your spine to have the minimum number of ports matching the number of leaves. If you have higher number of leaves, you need to pick a higher spine, like have higher number of ports. If you have enough ports to connect all the leaves, you really, when you want to add bandwidth, you can scale horizontally by adding more spines. So let's assume you have 64 ports, 64 spine, and you connect one port 100 gig to each spine, and you say, oh, I need more bandwidth. You can always add spines to gain more bandwidth. So you can go from 2 spines to 4 spines to go for 400 100 gig links rather than 2 100 gig link. Remember all of this. So when you design, you have to count from beginning, otherwise you have to build multiple fabrics, not a single fabric. The other thing is that make sure that you have enough spines. So if your bandwidth over subscription ratio need to have minimum 2 100 gig, don't design that you 100 gig go to one spine and another 100 gig to the other spine, because if you have a spine failure, your over subscription ratio actually doubled. Make sure that you always have enough if you have a failure. Measure your bandwidth efficiently. Like if you measure your over subscription ratios, make sure you have enough links to connect to the spines, whether they are 2 spines with multiple ports to the same leaf or different spines with different ports. So you need to know your east-west traffic. You can always have variable oversubscription. If you have like a certain rack with certain servers where they are hungry for bandwidth, you can always connect one of the leaves which need this bandwidth to communicate to the other servers with higher number of links. Not a problem. Fixed config switches is always an option. There is option, of course, for modular switches, but there is nothing wrong by building using fixed config switches. Even if you don't have enough ports, you can always build multiple fabrics. Either they are a single fabric without this border gateway function, like the first option I showed to you, where we don't have this border gateway and we don't terminate on the border gateway, the VxLAN tunnel, and the leaf will have peering with all the leaf on the other side. But fixed config switches is a good option. Fixed config switches consume less power than modular switches, so it's a good option. Most all the fixed config switches, the new ones, support in-service software upgrade, so you can really upgrade while the box is running. For me, if I design using a fixed config switch, for me personally, I would prefer it rather than a modular switch, because I can put like 2 supervisor engines in a modular switch. I have a pair minimum, each one has 2, but the second one is a standby mode. So I would prefer if I can design it using 4 spines rather than 2 spines. And I have all my control plane running at the same time and all the links going to different spine switches. Think always about the 100 gig power consumption and the 400 gig consumption, because like if you look to if you need more 100 gig ports, just ask your the person you are working with about like power consumption. Compare power between fixed config switches and modular switches. If you do a 400 gig design, the 400 gig QSFP consume 12 watts, a 4-port 100 gig consume around 17.2 watts. So power is important. It is not finite, infinite, sorry. It's a point to be calculated as well. So always ask for power consumption when someone do a design for you. You will be surprised how much power you can save when you change designs. And it doesn't mean that when you put more spines or you go for a 400 gig, it doesn't mean that it is more expensive. Sometimes it's less expensive to design using fixed config switches than modular. If you need modular switches, nothing wrong with it, but fixed config switches, it is a good option to be in the table when someone doing a design for you.
Hesham,
Yes.
I've got a question for you. So if you back up, right? So, you know, a lot of times when we talk to our customers and they're very insistent on, you know, building their network with modular switches, you know, dual supervisors, you know, multiple power supplies, because they're used to the resiliency and the redundancy in the chassis, right?
Yes.
But do you think it's fair to say that, you know, with VxLAN, like we build the resiliency and the redundancy into the fabric itself? Like we don't necessarily need, right, the modular.
You definitely don't need it. If you need it, yes, but think about the spine and leaf as if you have an Nexus 7K. Your fabric modules in the 7K is considered your spines, and your leaf is your line card. So you're already running this within the chassis. And using ECMP, really, if you build multiple spines, like 4 spines rather than like 4 spines, I'm assuming if I need 64 port, 100 gig, if I put 4 spines, rack unit wise, power consumption wise, is less. And then all my control plane is running. And using ECMP, if one goes off, I'm still have traffic going through the other spine. So usually, like with spine leaf type of architecture, if we really do the oversubscription right, and we do the design right, how many spines we have and all of that, we shouldn't be having the need for really a modular switch. If I have a modular switch with 200 ports, with like fully loaded with line cards and a lot of leaves connected, I would prefer to break it down to small fabrics rather than just connect everything to 2 spine. Even replacing and changing is much easier when you have a fixed config switch. Much easier. And I don't think, like practical wise, using if someone has 3-tier architecture like fabric extenders with 5K, 7K design these days, he will have enough cabling to run to the same aggregation switch. Like if you have a certain number of racks and you want to build like a 512 leaf switches, from cabling perspective, I see it rare that customers can run really cabling to this modular switches. So a practical solution is to break it to fixed config switches, top of the rack, middle of row, and then aggregate that. And you will, if you do this type of design, simple kind cookie cutter kind of design, everything will be very simple to get deployed and troubleshoot as well. I put a couple of options which usually we see with customers. So the green device box is like you have the border gateway spine 1 and spine 2. You have the leaves, whatever number of leaves. We can scale up to 512 leaves. And then in a multi-site, we can per fabric, and in a multi-site, we can scale up to 256 leaves within one fabric, and up to 25 fabrics. This is more than 6,000 switches. So basically, I put here leaf 1 and leaf n, pod 1 and pod n. So pod n here can go up to 25, but nothing stopping you to build more. But when I say 25 fabrics, mean that my layer 2 domain can be extended up to 25 fabrics. Each fabric have 256. But this doesn't mean that you can really build additional, but your layer 2 boundary will be only within 25 fabrics with 250 times 256. So basically, if I build a multi-site kind of a design with hierarchical kind of a design with a border gateway function, you will have your leaf. You'll have border gateway. Border gateway can be a separate function on a separate switch. There is some design customer deployed this way, and it can run on the spine as well. So the spine can act as a spine, and it can act as a border gateway. Then the border gateway spine will be connecting to a route server, and a route server function is like, if you are familiar with BGP and IBGP with route reflector. So when you build an IBGP design, you have route reflector. So rather than you have full mesh in an IBGP like this leaves, you have a full mesh of BGP between the spine and leaf. You configure this as route reflector, and then your updates will be sent to the spine, and the spine sends updates to all the leaves. Route server do the same thing. So rather than I have full mesh between all the border, because this is, I'm showing you 2 fabrics, but we can have up to 25 fabrics. So rather than I have full mesh between all of them, you put something called route server. Border gateway spines in each fabric will send the updates to the route server, and the route server will reflect this updates to the other fabrics as well. So this simplify definitely config a lot. So this route server will be used like you can think of as east-west traffic between the fabrics. And then if I want to go to the outside, because you must have a way to go to the outside. You can go outside from each leaf, but I didn't see customers would like in your design today, most probably you have an aggregation switch and your router and firewall and everything is connected there. So if you want to mimic this kind of a design, you deploy something called share border. Share border will be having your routers to the outside, maybe firewalls, load balancer connected to the outside world, and you go out from there. So rather than you have connection in each leaf, each row, you just have in the networking rack, you will just connect there. So this is one of the designs which is really available. So what is not good about this design? This design, because every time you add a pod, like this green rectangle pod, you need to connect to the route server, you need to connect to the share border. So from cabling perspective, sometimes it's more redundancy because like if route server fails, you can go out through the share border, but it adds complexity from cabling perspective because you have to connect to both of them. So, and definitely there is additional configs need to be done. The most common design is this kind of a design where you still have a leaf. Border gateway can be on the spine or a separate 2 switches. It can be this way, but most customers really do border gateway on the spine itself. And then you have a route server layer. This can be 2 switches, 4 switches, depending on how much traffic and how much bandwidth you need between the different fabrics, between your rows, for example. And then this route server is connected to the share border. This design from cabling perspective is much easier because what will happen is that the moment you add a new row, this row will be connected only to the route server. You are not touching the share border. And you have enough resiliency here because you can have, rather than 2, you can have 4, 6, 8, and then you can scale depending on what you want. You can have modular switches if you would like more redundancy here, but there is no need. But there is multiple options you can have for a route server. Route server basically run BGP. There is nothing fancy on it, only BGP config there, no VxLAN whatsoever running. The share border, basically it will run VxLAN because you have to terminate VxLAN, and then it go classical Ethernet to the outside because of your routers, firewalls, all of that will be using only classical, no VxLAN. This is most common design. You will see it even in design documents we have, but this is most common design. Sometimes customers say that we don't have big networks, we just want to have collapse everything. You have an option as well to collapse share border with a route server as well, where you have the 2 switches connecting between the fabrics and also terminating VxLAN on it and going to the outside. There is multiple options. This is a routed design. You can do magic with it, but this is the most common designs we always see. From migration perspective, there is documentation available, step-by-step with configs available on Cisco website, which go into details how you migrate. There is documents to migrate from Fabric Bus environments to a VxLAN EVPN environment. You can migrate from a classical Ethernet environment to a VxLAN BGP EVPN environment, and it's very well documented, tested, validated. This is the name of the documents. Please go through them, very detailed with configs as well, with steps, everything with step 1, 2, with like very detailed. Anything before I go to the management so far?
I don't see any questions.
Okay. So from management perspective, we have something called Nexus Dashboard Fabric Controller, and basically it's really an app. We have something called Nexus Dashboard, and Nexus Dashboard can be virtual, it can be physical. Basically, it's a 3-node cluster. In Nexus Dashboard Fabric Controller, which is the app used to manage VxLAN EVPN, you can deploy it on one, but basically, if we think about best practices, it's a cluster of 3 VMs or a cluster of 3 physical servers. And then you have Nexus Dashboard as a hosting platform where you deploy different apps on it. So what you see on the screen is different type of apps. There is Nexus Dashboard Data Broker. There is Orchestrator to managing multiple Nexus Dashboard instances, managing multiple ACI environments. You have Insights for telemetry, hardware telemetry, ingestion from the switches. You have a Fabric Discovery app. There is a Fabric Controller for Nexus for VxLAN EVPN. And there is another SAN controller, which is based on Nexus Dashboard Fabric Controller for MDS. What I will show you quickly, I will show you so I have an instance which called Nexus the Nexus Dashboard itself. If we go there, so this is a platform. I have a single VM because it's a lab, and you can see that this is a platform. And then what you do is that you install apps on it. And Cisco has an app store where there is apps running. One of them is this NDFC. I have an issue because it's my lab, but there is an app store available. And then what you do is that you download the app and install it. And I have this Nexus Dashboard running on it. So the Nexus Dashboard is an application to host these apps on it. So if I click here, I will open the Nexus Dashboard Fabric Controller app itself. So first, you will see the topology. So I have 2 fabrics, so it can manage multiple fabrics or a single fabric. So here I have 3 fabrics running. I will show you where I'm running this fabric when I show you the switches, but basically I have a fabric. This is gray because the fabric is shut down because I don't have enough CPU and memory, so I did shut it down. So this is showing 2 fabrics. You can have 1 fabric, 2 fabric, 3 fabrics. There is a scale guide to show you how many fabrics and how many switches we can manage. Today you can go 350, soon it will be 500 switches, but there is a scale guide which show you exactly how many you can run. So basically this is a multi-site kind of a design. So there are 3 fabrics. So this is one of the fabrics. Go through it. So I have a border gateway spine, two of them, and then I have 2 leaves. This gray is showing that it's VPC connected. VPC is very simple. All what you need is that you do VPC pairing, and all what you need is choose. Of course, this is VPC is already done, so it will give you, there is no option because it's already selected. So all what you need is to say that this is a VPC and I want to pair with this switch, and that's it. VPC config will get created and pushed. If you don't have any switches here, so what will happen is that you can add switches, and there is multiple ways to add switches. You can add switch manually by adding IP addresses. So if I want to add switches here, I can just add a seed switch, and the IP address puts the username and password. You can choose if it's already configured, you can preserve config on it, or if you uncheck this box, it will go and wipe the switch, only keeping the management IP, the boot command, and the static route under the VRF on the switch to be able to reach it. Otherwise, it will delete everything. You can choose to reboot the switch when you delete the config, or you can delete the config without rebooting the switch. You can do bulk import of switches. Like let's assume you are installing a new DC, you have 200 switches. Using the serial number of the switch, you can build a CSV file with all the information, switch name, and then it will go and import and configure the switch for you. If you don't want to even use CSV file to do bulk import, or you configure the switches on your own, what will happen is that you can do power on auto provisioning, and then you will the switch will boot. It will do its pop, and it will go and connect. If you don't have because NDFC is a DHCP server as well. So if you don't have another DHCP server running in the management network, this request will come to NDFC, and the NDFC can onboard the switch to the fabric and push the config to it. So there is multiple ways for you to add switches here. This fabric is already built, but basically if I don't have any switches, this is the template for the fabric. So we have for VxLAN EVPN with IGP underlay, we have something called Easy Fabric. So if I'm building just a new fabric, all what I need is first to choose a unique AS number because of overlay will run BGP. Say that I want to have my fabric interfaces numbering to be, it's a point-to-point. It can be /30. You can use unnumbered and rely on the loopback, but you can also use point-to-point connection with /30 or /31. And all what you need is to give IP addresses in the resources, which I will show you, to give the subnets, and NDFC will go and subnet this subnet and give IP addresses to all interfaces without you touching anything, and it will configure it for you and do everything. It has a resource, it tracks all the IP addresses, so there is no way that there is a conflict IP address happen or anything. So it will do all of the configuration for you, subnetting, and will track all the IPs. From replication perspective, I'm using ingress replication. Sometimes customer like to use multicast. The same thing, multiple entries you put here, and it will go and configure multicast or ingress replication for you. VPC, this is the settings for VPC. Couple of settings. What we'll do as well to help customers is that we populate this template with like the default configs, what we see that default best practices, but you can always edit it. But it will be like I didn't edit anything in this VPC config. It's pre-populated for me, and if I want to edit it, I can, but usually it's pre-populated for you. Protocols, underlay, I'm using OSPF, couple of entries of config, and you are up and running. Like you really don't need to configure much. If you use OSPF, nothing to do unless you want to configure based on something you have in your best practice. Some VRF other templates for other things. MTU size, it's by default it is Jumbo MTU 9216. Hold line timers, this is all populated and checked for you, whatever best practice. If you want to change it, you can change it definitely. Resources basically to give IP addresses, subnets for NDFC to use to subnet and distribute these IP addresses, to choose loopback IP addresses, uplink IP addresses, all of this IP addressing for underlay you will get from this templates, and it will track all these IP addresses for you. And VLAN ranges to use. When you create a new VLAN segment, you can put a range. You can always define your VLAN when you are creating a new segment, but if you want to NDFC to choose the VLAN segment for you, you can always rely on it to choose. Management, if you have DNS, syslog server, NTP server, you can use that. Bootstrapping, if you want to use it. So because you can use it for power on auto provisioning, so everything can be part of this template. You can do config backup as well. So you can do schedule backup every time, an hour to do a backup as well. So if there is any change, it can be done. And then if you if you want to enable NetFlow and export it somehow, you can configure it as well here to configure NetFlow and export the NetFlow to the outside. The moment you do this template and you discover the switches, all what you need to do is to deploy, really. So if I go to here, for example, detailed view switches, if I have my switches, they are in sync now, because like what we do is that the template, you create something called intended config. This is the config you want to push to the switches. This is your intention. What will happen if someone goes, because you can go through the CLI, if you have a username and password, you can go to the switch and change the config. The moment you change the config, NDFC keep pulling this config from the switches and comparing it to the config it has as you created part of the template. If it see a difference, it will show red on the switch, meaning that the switch is out of sync. There is config on the switch, doesn't match the intended config. Maybe you enable the feature on the switch, which you didn't configure on NDFC. So it will show red, and it will show you a difference. So it will show a diff and what is the difference in, and then if you want to deploy, you can deploy. So it can show you that. So you will know exactly what is the difference. So it can give you a diff as well. So if I go here and say, now it is in sync. So if I do a deploy, nothing will happen because it is already in sync. So it's not red or anything. It can show gray or blue. So gray meaning that it's unreachable. I don't know the switch. Maybe I cannot reach the management IP. It will show blue as well. Blue meaning that it is pending deployment. So like in sync meaning that the config on the switch match whatever in the template. Pending meaning that it is at a time where configuration being pushed to the switch. And yellow meaning it is in progress. So the moment I change anything in the template, it will show blue, meaning that there is config and ready to be deployed. The moment I push it, it will show orange. And then if it is different, it will show out of sync. And if it is not available, reachable, it will show not available. Building multi-site is easy. So this is a multi-site setup. This is one of the drawings I was showing to you. This is the route server. This is the border gateways. And multi-site is very easy. So I can edit the fabric and give a couple of configuration items as well. And that's it. I mean, you build the multi-site setup. It's very easy. Couple of clicks and it's up and running. If you add a new fabric, you build already a fabric and you want to add it, you can add a child fabric. So of course, I don't have all the fabrics here are already part of the multi-site, but if I have a fabric just deployed, I will see it here. And if I want to add it, I will just say select, it will get added. And what will happen is that NDFC will deploy the needed config for this multi-site to happen. So no need for you to configure anything, everything according to Cisco best practice. If a switch fails, if I have a fabric and I have a switch failed and I want to do an RMA for it, for example, all what I need is that put it into maintenance mode and do an RMA. RMA meaning that it will retain its IP addresses. It will not return this loopback IPs and uplink IPs back to the pool to be available for another switch. All what you need, it will put it into maintenance mode, and you can add the switch, discover the switch, say that this switch now is border gateway 232, and it will push the exact config back to that switch. As easy as that. You don't need to worry about config matching or anything. So to be able to config this, all what we need is that after you create the template, you set the role. So if I have different type of roles here. So if I say this is a leaf, the template will push leaf type VxLAN config to that switch. If I say this is a spine, it will push spine config to it. If I say it's a border spine, it will push border spine config to it. So depending on the role of the switch, the necessarily configuration will be pushed to that switch, as easy as that. So you don't need to worry about like any other config. This one is a leaf. This is a current, but I can change it to something else. If it is deployed as leaf, you cannot change it. But if it's a new switch, let's assume I'm having leaf 131, 132. I'm adding leaf 133 and leaf 134. I have to say this is a leaf, and the template will push the right config to it, and configure all the uplinks, OSPF, config, BGP, everything will be pushed to it. Last thing I want to show you is where I'm building this. So we have something called Cisco Modeling Labs, and it's just a single VM, and then you start building this. So this lab is built virtually. This is a single VM running in my lab, and this is the switches. So currently I'm having this 4 and 4, and I didn't add these 2 yet. And then all what you need is that to add more switches. So if I want to add different switches, you have firewalls, and this is a complete lab. So even hosts, this is a control plane and data plane as well. It's not long only you push config, but you can connect hosts. So you can put NXOS Linux Ubuntu host. So here I have Ubuntu hosts connected, and you can verify VPC config. You can do VPC to the switches. You can build multi-site, and you can ping across sites as well. So all of this can be done, and you can upload your own as well. There is a way, a step, like a guide, show you if you want to upload your own VM here. It can be done as well. You can run different codes. So you can run a fabric for a code and run a fabric for another code. You can verify your config before you deploy it. I use this a lot to build customer setups here for demos. So when I build like NDFC, if the customer would like to have a certain design, I can go here and deploy the same design with the same config with the management as well. So this can be local, but you also can connect it to the outside. So you can connect it using your routable IP addresses, and from your desktop, you can SSH. So here I'm not doing like the management IPs is not routable outside. So what I'm doing here, this is the like console. So you can connect to the console. It's a full-fledged switch, and you can run. You can add interfaces, increase interfaces. Here is the interfaces, and all what you need is to drag and drop interfaces to build this. So if I want to connect this to this, what I need, I just drag and drop the interface. So it becomes much easier for me. Like if I want to build a 16 switch setup, I don't have 16 switches, and I can not even get them on time. All what I need is to build 16 hosts here, and that's it, and I'm done. And I build the lab. That's all I had, to be honest. So I'm not sure if there is any questions or you want to ask any question.
Any questions for Hesham? Jason, were you going to ask something?
No, I was. Okay, so I finally came off mute. I wasn't sure if my WebEx was working yet or not. No, but this was very good, and you obviously have a lot of experience with this, Hesham. So I thank you for taking the time to go through it tonight, for sure.
So thank you. Thanks a lot.
So we'll get a copy of this deck and also the recording. And Jason, you'll send out the recording link and everything else to the group here, or to the wider audience, I should say, not just the group here.
Yeah, I usually post the link and all that information up on LinkedIn, to be honest, but I can also just send it to everyone I have an email for that registered. I don't want to spam people that didn't come or didn't register or something like that, but yeah.
Okay. All right. Excellent. Okay, I'm going to stop the recording.
Need help? Call our cybersecurity team and book a consultation with us today.